Let's discuss the third problem of today's weekly contest, maximum product after k increments. So we are given an array of non-negative integers and we are given an integer k. We can perform several operations. In one operation, we can choose any element from this array and increment it by 1. Now, our goal is to find the maximum product of these nums after performing this operation k number of times. So remember, like we don't have to perform all the operations. Like we have to perform at most k operations. Okay. So since the answer could be very large, we just need to return it uh, with some modulus. So let's try to understand this with an example. So let's say this is the array 6 3 3 2 and k equals to 2. It means we can perform two operation at max. So what is the operation? We can choose any element from it and increment it by 1. So let's say in front of first operation we increment this 3 to 4, and then second operation we increment this 2 to 3. So the final product would be 6 into 3 into 4 into 3, which is 216. Okay, so that is one possibility. Now let's just try to solve the question. First we have, like you can see, we have to perform at most k operations. So let's just try to understand whether it makes sense to like in which conditions it makes sense to not perform all the k operations. So we have to maximize the product. So we have to maximize this 6 into 3 into 3 into 2, like this product, right? Whatever we get after performing the operation. So if let's say we don't apply any operation here, or let's say we lift some two operations here. So in that case, this is the product. But why should we left two? Like we have to increment the we have to increase the product, right? So if we just increase this 2 to 3 as well, the product will increase a lot. So that's where, like, hope you are also convinced that we will not, there will not be any case where we not exhaust all these k operations. So even the problem says that we have to perform at most k operations. In every scenario we will perform all the k operations that we have. So that's the first observation. Now the second is basically, let's just try it, like as always, as I always say, let's not before solving the actual problem, if the actual problem is very hard, let's try to solve a smaller version of the same problem. So let's say there are only two elements in the array, 2 and 5, and k is 2 only. Okay, so now we have to perform two operations. So what are the possible choices we have? So either we can increase this to 3 and increase this to 5, like one operation, or we can apply both operation at 2 to make it 4 and this should be 5, or we can make both the operation at 5 to make it 7. So these are the three possible cases, right? Now if for this the value is 15, for this the value is 20, and for this the value is 14. Okay, so clearly 20 is the maximum value, but now how we will end up being here? So you can think of it as like you have to maximize the product a cross b, right? So to maximize the product a cross b, you can think like, what is a cross b? In geometry you can think of a cross b as a area of a rectangle. Okay, now you have to maximize this area. So there is a very well-known theorem which states that for among all the rectangles, the square has the largest one with the same perimeter. Okay, so the proof is very simple. We just need to apply the same differentiations that we study in class 10 12. So area is x cross y. Okay, and the perimeter is 2 into x plus y. Now we just arrange this, arrange x in terms of y, uh, or arrange y in terms of x, and then put y in this area. So now if you want this area to be maximized, we the differentiation of this area with respect to x should be equals to 0. So we, after differentiating, we get x equals to p by 4. And to like, if you remember, after double differentiating, if the value is less than equals to 0, then it is maximized, otherwise it is minimized. Okay, so indeed, putting the value to equal to 0, the value is negative, so it means the expression a equals to x cross y is maximized at x equals to p by 4. Okay, so if we just put x equals to x, the value of x in this expression, we will get y equals to p by 4 as well. So it means the area will be maximized if x is equals to y. Okay, so that's the basic assumption here. So what we are saying is, we also have to find a cross b such that a cross b is maximized. So from this theorem we can say that this will be maximized if we try to make a is equals to b. So you can see in the previous example as well, the maximum value was 4 cross 5, wherein we were trying to make A and B as close to each other as possible. So here the difference is 1, so that's where the maximum value comes. Here you can see the difference is 5, difference is 2. So that's where like the maximum value arise when the difference is minimum, or basically when they are approaching to each other. Basically they are equal. So that being said, for two numbers, like for an array of size 2, we are sure that we need to try to make both of them equal to get the answer. Now, what about the case where the size of the array is larger than 2? So basically, let the size of the array is k. So in this case as well, you can think of it as k dimensional square. So this is a k dimensional figure, and this we have to maximize this, like the product of this. So this will be the area of a k dimensional figure, and we have to maximize this. So this will be maximum similar in similar scenario. Basically this is the maximum in case a1 equals to a2 equals to a3 equals to ak. So basically what we are doing is, we will take the minimum one, we will increment it until it gets equals to a2. Now a1 and a2 are equal, then we will start incrementing these two one by one to make them equals to a3. Now when these three are equals to a3, we will start incrementing all of them so that they are equals to a4, and so on and so forth until we exhaust k. So basically our target is to minimize the difference between the smallest and the largest element of the array. Okay, so this is a very standard problem. Let's just try to reiterate over it with an example. So this was the sample that we have given, 6332, and we have two operations. So we can see the difference between smaller and the largest is currently 4. So we have to minimize this difference, right? So what we will do is, we will first or let's assume that it is 4, it is 3. Okay, k is 3. So now we will first increment this value, because that's the minimum one. Now minimum is 3. So like we have already exhausted one operation, so now we are left with two operation. So now minimum is 3. Then we will spend one operation and increment this to 4. Okay, now again the minimum is 3. Like we will not increment this now, because uh, minimum is now here is 3. So we will exhaust one operation and convert this 3 to 4. Now we have exhausted all the operation, and that's the final answer, like 6 into 3 into 4 into 4. If we have one more operation, let's just assume that if we have one more operation, in that case we will increment this 3 to 4, because again we have to minimize the difference between the smallest and the largest element. The smallest is 3, largest is 6, so we want to minimize the difference, so we will increment this 3 to 4, so that the difference is minimized. So hope you got the intuition. Now the solution is very simple. We just need to, we will just take the minimum, uh, remove the minimum from the array, increment it one, and then add it back to the array. That's what we are doing. So we need a data structure that can add an element that can get that can give us the smallest element in efficient time, and then that data structure should be able to remove the smallest element in efficient time as well. So basically, that's the three operation that we need to perform. So by these three operations are standard heap operations. So getting the smallest element is the standard heap operation in order one time. Removing the smallest element is order log k time heap operation, and again in heap we can add an element in order log k time. So let's look at the solution. The solution is very simple. We just take a priority queue, that's a heap in C++. We push all the element to the queue. Now we perform this operation one by one. We take the minimum, pop it, and then push minimum plus one into the heap again and decrement one operation. We will keep on doing this. This will make sure that the difference between the minimum and the maximum is minimized. So after doing this, we will just take the product of all the integers. So that's the complete solution. In case you have any doubts in the solution, please ask them in the comment section below. I will answer them. If you like the video, please give it a like and consider subscribing to the channel. I am publishing regular videos of interview questions. I will paste the link of all the playlists in the description below. You can check them out as well. So thank you.